Hello everyone, welcome back to my channel where I take you through the ins and outs of openSUSE Linux. Today we are going deep into advanced system administration with a special focus on several critical topics. We will explore the YaST security module, Snapper for backup and recovery, understand software libraries, monitor your system's health, and finally we will dive into system optimization tools like tunded and Linux control groups, cgroups. Whether you are managing a server or your own machine, these advanced techniques will help you maintain performance, security, and efficiency. Let's jump in. Let's start with the YaST security module. YaST, which stands for Yet Another Setup Tool, is a key feature of openSUSE Linux. It allows you to configure various aspects of your system, and one of the most important is its security center and hardening tool. So, accessing the YaST security module, you can open YaST by either like here, and we search for YaST, or you can open it from the command line, and don't forget to enter your sudo password. Okay, it seems I entered it wrong. So as we can see here, this is our YaST, and from here we go to security and users and select security and hardening. We check these here and security center. So let's open. This module offers a wide range of controls for security hardening, password policies, and boot permissions. So let's explore, like for an example, password settings. Okay, and here you can enforce password rules such as minimum password length, setting it to 12 characters, password expiration, forcing users to change their passwords every 90 days or something, password complexity requiring uppercase, numbers, or special characters, and also the encrypted algorithm that's used for that. Okay. Uh, for instance, if you are managing a server, it's important to enforce restrictor password policies. Let's set a minimum password length of 12 here. Okay. And we can change the history of remembering passwords. Like let's make 5 means the user cannot use the same password he used in the last 5 passwords created before. Okay. And we have here days before password expires warning. We can leave it 5. Password age, we can change it here. Minimum, we can make it 7, that the user cannot change his password till after 5, but we can make it like 1 day. Okay. And here we can make it like 90 days. Okay. And you can just press OK, and these parameters will be applied. Okay. So another thing that adjusting boot permissions. So let's go to boot settings, and we can see here, let's enlarge this. And as we can see here, for enter operation of control alt delete, here the default is reboot. System hibernation users on the active console, and you can change the parameter that you would like to be applied on your system. Okay. So as we can see here, delay after incorrect login attempts. After 3 times, the user will be logged in, and you can allow remote graphical login here. Let's check another one. We have here the predefined security configurations. Okay, you can do for workstation or roaming device or network server. Some policies and profiles will be applied on your system. And here we need to check something. So what I was trying to find this one here to make the file permissions on your file system, the default is easy, secure or paranoid. And if you choose secure or paranoid, it will make your system maybe will not be functionable if you're already using it for some time. So this advised only if for a new installation before you install, like for an example, you are creating a server for acting as a web server or a database server. You can start after the installation directly. You can make it secure or paranoid. It will change all the file permissions on your system and make it really restricted. And from that point, you can start giving access accordingly to the situation. Okay. And here we can see the user addition. Like when you create a user ID, you want the starting and the maximum. It's automatic. When you create a user, what ID, what the range of the ID that the system will give to the new user or to the new group. And we talked about the login, and we have this boot settings and the password settings and the predefined security settings for the whole system, if it is network server or roaming device or workstation system. Okay, so let's move forward and talk about another point. In this section, we will go over backup and recovery with Snapper, and yeah, we spoke about it before in a dedicated video, but we have to talk about it again here because the Snapper is one of the most important aspects when it comes to openSUSE or SUSE Linux in general. So for the newcomers, let's explore Snapper. That is an excellent tool for backup and recovery using PTRFS snapshots. Snapper allows you to restore your system to a previous state, making it perfect for recovering from mistakes or failed updates. For an example, sudo snapper list to list the existing snapshots took by Snapper, the automatic snapshots. So, what is Snapper? Snapper creates and manages snapshots for PTRFS file system. Snapshots are system states captured at specific points in time, such as before and after system updates. So, to set up Snapper, if you are using PTRFS, which is the default file system on openSUSE, Snapper is already installed. To configure Snapper, you can use YaST or from the command line. So here, as we can see that we have a list of snapshots, and we can see, excuse me, that we have pre and post for each task happen on the operating system, and here the description if it is zipper or by using YaST. So we can see that it is already configured for /root file system, and Snapper automatically creates these snapshots for system updates. But you can also manually create a snapshot before making major changes. Okay. To manually create a snapshot is straightforward. Sudo snapper, okay, create, and you have to put a description, okay, and the description you want to put before changing something, okay, and after you do the changes you can create another one after, and you can, like if I hit enter, so and we do list again, we should see it created there. And let's say you changed something, you can just simply roll back to this snapshot. So as we, yes, here, okay, and you can just run sudo snapper roll back, okay, and the ID of the snapshot. and your system will be rolled back to that point. So Snapper is an essential tool for managing and recovering your system in openSUSE, especially in environments where stability is crucial. Moving on, let's talk about software libraries in Linux. Libraries are a fundamental part of any system, providing pre-written code that applications can use. Let's take a deeper look at how they work. What are software libraries? In Linux, there are two main types of libraries. Static libraries, these are included in the program when it's compiled. Shared libraries, these are separate files that many programs can share and access at runtime. Viewing shared libraries. To see what libraries a program uses, you can run the ldd command. So we can do ldd and then ls for an example. And this lists the shared libraries required by the program. And also, as you can see, that ls command relies on various shared libraries, such as libc, which is a core library in Linux. To verify the integrity of installed libraries, you can use sudo zipper verify. If there are broken or missing libraries, Zipper will attempt to repair them. So dependencies of all installed packages are satisfied and all good. Let's move forward. Server health monitoring is crucial to ensure that your system is running optimally. Let's look at a few ways to gather and monitor the health and performance of your openSUSE system. For real-time monitoring, you can use stop. Okay, you can use stop. A better one is htop, and the much better is btop. It is not installed. If it is not installed, you may install it in this way. Zipper install btop, and the refreshment. Let's wait for okay, yes. Let's run btop. As you can see, btop provides a detailed view of system resources, including CPU usage, memory consumption, and active processes. Okay, so to get a detailed log of system events and errors, you can use journal control -p 3 and -xp. And this show critical system messages and warnings. So we only have one, and it's related to the dbus for the desktop. So nothing serious with the operating system. Okay. And for this command, in some cases, is extremely useful for diagnosis problems. For example, if a service fails, and journal control will show you the error and when it occurred. Okay. For monitoring network connections and performance, you can use the ss command, and let's use sudo and -t l u l n p. Okay, and this command will show you all the open ports on your system with the process that's running on that port. And T for TCP, U for UDP, and L for listening, N to show the IP, the actual IP without using DNS, and P for showing the process that opening or listening on that port on your system. Finally, let's get into system optimization tools. openSUSE provides several ways to fine-tune your system's performance. In this section, we will cover tunded, a dynamic system tuning tool, and how to use cgroups for resource management. Let's start with the tunded. Uh, just in case, check if tunded is installed on your system by running this command, tunded. And tunded is a tool for automatically tuning your system's performance for different workloads. So it's already installed. If it didn't install on your system and you just install it, you after the installation start the service and enable it to run at boot time by running sudo system control enable now tunded and hit enter just to check the service is running and nothing wrong with it, like that. Okay, so tunded has profiles. Tunded offers several profiles to optimize your system for different purposes. We have balanced for a general purpose workloads, power save to minimize power consumption, latency performance for low latency tasks such as gaming or multimedia editing, throughput performance for servers or high throughput workloads. So to see the available profiles you have, run this command, tunded add and list. And as you can see, all the profiles that you can use. To apply a profile, for example, latency performance, you can just like that, profile and latency performance, and you hit enter. Before that, if you would like to see which profile your system using, you can run active and it shows us it's a virtual guest, because as I said before, it's a VM. And this is to show how openSUSE as an operating system is smart enough to understand that it is installed on a VM and choosing the right profile for that. So as we said, if you want to apply the profile needed, and you choose the profile name from here: desktop, CPU partitioning, balanced, network latency, okay, throughput performance, latency performance, and here a small description about the option, and it is clear enough. Okay, in case you want to edit one of these, like creating a custom profile, you can do the following. Okay, by let's first list the existing profiles for tunded, and we can see here the profiles that's coming loaded with tunded. All you need is to sudo cpr and usr lib, okay, tunded, and let's say I will choose the parsave to etc tunded, and whatever the name you want, custom, because under this folder is files, so you can edit the configuration there. You can alter it according to the situation or the needs in hand. So I will name it custom profile, and let's run this and we see if it is there or not, because yeah, it became here now. And of course it getting the information, the default one in the files. If we go there, etc tunded, and the name that I chose for that, you will find two files, the one tunded for the configuration. Okay, you can go through the configuration and you change accordingly to the situation you have. And here the script that running when you choose this profile. Okay, if you need to alter anything here. So this is for using tunded to tune your system for the needs or according to the situation you have in hand. One more thing to end this section, which is sudo. We have to mention this when it comes to tuning. If we run this command and I have to pipe it to less, it gives you all the kernel that parameters that it is loaded now in the memory. Okay, so you can alter them according to the needs. You can change the value, but it will not retain after a reboot. You have to edit the configuration file for that. So I will give a small example. Like, let's say I'm looking for the swapness. Okay, so it is vm.swap. So as we can see here, it is the amount of the swapness, and I want to adjust it. I can adjust it now in the command line, but it will not retain after reboot. So to make it sustain reboot, sudo vi etc sysctl conf. Okay, and we take this copy and we edit it here in the file, and we just add it like that. And I will change it to, now I want to use less swap space. So instead of 30, I will use 15. Okay. And this command, it was I, the parameter here. Let's remember which one. Yeah, this one. So all we need is -p etc, okay, sysctl.conf. And when I search about this value again, we will find that it is changed and it will retain system reboot. So this one you can use to tune anything on your operating system. And I strongly advise to go through the official manual openSUSE for tuning your operating system, and you will find a ton of information there and how to change these variables. So let's move forward. Another powerful optimization tool is control groups, cgroups. This allows you to limit and manage system resources like CPU and memory for specific applications. We have to mention that openSUSE Leap 15.6, the way cgroups is managed has changed, particularly due to the adoption of cgroups version 2, which consolidates resources under a unified hierarchy instead of having separate directories like in cgroups version 1. For example, /sys/fs/cgroup/cpu. This is why some of you will see errors and missing directories when trying to interact with cgroups in traditional way. To manage resources using cgroups version 2 on openSUSE Leap 15.6, the process is slightly different. So let's go through this update step by step. As I said, openSUSE Leap 15.6 uses cgroups version 2, which simplifies resource management by using a single unified hierarchy for all cgroup controllers. Let's start by checking if cgroup version 2 is enabled, and to verify that your system is running cgroups version 2 by checking the mount point. So mount, and you do grep cgroup 2. So now we can see the output is that cgroup is mounted on that path. Okay, so if you see that output, your system is using cgroups version 2. To limit CPU usage with cgroups version 2, let's create a new group under the cgroup version 2 hierarchy. And let's run this sudo mkdir and sys fs c group. Okay, I will name it my c group. Okay, and we press enter. In cgroups version 2, we use the cpu.max file to set CPU limits. This file controls how much CPU time a group of processes can use. Let's limit CPU usage to 50%, for example, 50 milliseconds of CPU time per 100 millisecond interval. So let's run this together. Echo 50,000, 100,000, and you grab it to sudo t sys fsc group. Okay, and the name of the group we created, cpu.max, and we press enter. The first value, 50,000, sets the maximum CPU time in microseconds, and the second value, 100,000, sets the period over which that time is measured. Here we are giving the group 50% of the CPU's time. You can also limit the memory usage of a C group by using the memory.max file. So for example, to limit a group of processes to 1 GB of memory, let's write the following: echo 1G, and we pipe it to sudo t sys fs c group my c group and memory dot max. Okay, so I will stop for let's explain this. This sets the maximum amount of memory that processes in the group can use. If a process tries to use more, it will be killed. So just to explain why we are doing this, to create a file or to edit a file. Because if you used a normal text editor, you will get some kind of error message that you have no permission, you cannot write, even if you are root. Okay, so this is the only way to edit files or to change a parameter inside these files under /sys. And for the command T, to say it well, it's read from standard input and write to standard output and files. So once you give it the file, so it becomes the standard output here. So it will take what is coming from the input source and will write it here to the file. Okay. So now we created a C group, and we limited this group, the CPU limit, and we limited the memory also. So to assign a running process to this C group, first find the process ID or PID of the process you want to control. For example, let's say the process you want to limit has a PID of 123. Okay, 1234. So to assign the process to the C group, you run echo 1234 sudo sys fs c group and the name C group. Okay, and C group dot process, and you press enter. Command not found. We forgot the T. Okay, but of course it will tell us no such process, but if we try to cat on it, because it's just an example, it is not there because it couldn't find this process number. And you should actually have the process ID, and we said before that to list all the process ID you can do psux and pipe it to less, so you can check the process ID that you want to control. So this moved the process into the new C group, and it will now be subject to the CPU and memory limits we have set before. As you can see, cgroups version 2 allows for fine-grained control of CPU and memory usage for specific processes. This is especially useful in server environments or for running resource-heavy applications. So now to monitor how much CPU the C group is using, check the cpu.stat file, and you can check that in this fs C group, my C group, and this file automatically created by the C group service. And yeah, we will not see anything here. Yeah. So you can monitor the CPU usage from this one, and this file got created by default. Once you created the C group, the C group service will create the needed files to monitor the process. And for the memory to monitor it, it's memory.current, and of course it is 0. And this will show you the current memory usage of the process in the C group. But because we don't have an ID, process ID here, we can just to complete the example, let's take something. Okay, I will open here and I will run htop. Okay, and I will come here and I will get this process ID. Okay, so we have it here, and I, instead of 1 2 3 4, I will use this process. Okay, so now we should see some kind of variable here for the memory, and let's check the process, the CPU, and now we have changed variables here for that process, because now the htop process that we run in the terminal, now it is running inside this C group. And the same concept you can apply it on any application you have. You want this application, or maybe compiling, like you are compiling a source software and you want to control the usage of the CPU and the memory. Okay. And that's it for today's video. We covered a lot of ground, from YaST security to system snapshots with Snapper, and even advanced optimization tools like tunded and cgroups. Whether you are tuning a server or managing a desktop, these tools will help you get the most out of your openSUSE system. If you found this video helpful, give it a like and subscribe to my channel for more in-depth tutorials on Linux. Thanks for watching, and I will see you in the next one.